HIMT, Hindustan Institute of Maritime Training.
Okay, so we are going to start off with the theory. Okay, what is the theory behind the radar? First we'll learn about the radar and then later on we'll be going into the art part. So as far as the radar is concerned, we have two types of motion, relative motion as well as true motion. So what do you understand by relative motion? What is relative motion?
The other ship is one ship is stationary and the other.
So if your own ship is moving, how is your ship shown stationary at the center of it? Your ship has got a motion. Okay. When your ship is moving, why is your ship shown stationary at the center of the screen? Isn't it better to have your ship shown as moving instead of stationary? To understand this, you must know something about the background of radar. Radar was an invention far ahead of its time. Radar was first invented in the early 19th century. At that point of time, even a gyro was not invented. So since there was no gyro, you cannot stabilize the radar. At that time we had only magnetic compass. So this was the reason why, since radar was not gyro stabilized, we could only have relative motion. You can't have true motion without your course, can you? No. So only relative motion was possible. And at that point of time, to keep things simple, they kept your own ship stationary at the center of the screen. And as a result, all targets were shown moving in relation to your own ship. Whether the target was stationary or a moving target, it was shown as a moving target. Even landmass, if you had a landmass here, and say you had a ship over there, how will this landmass move? On the screen, will the landmass move or not? Yes? So how will it move? Okay, let me say, my ship is doing a course of 000 at 12 knots. On the screen, how will you see this landmass moving? On what course? 180. It will come down in the exact opposite direction and also at the same speed as your ship. Okay. Now, if this was a ship which is moving, let us say 270 into 15 knots, how will this is actual course, but this is not what you see on the radar. How will this ship be shown as moving? Your own course is 000, 12 knots. That ship is moving at 270, 15 knots. How will the ship move on the screen? Will it move on its own course and speed? No. Then how will it move? Not opposite. Okay. See, your own motion, since your own motion is not being shown on the radar screen, it has to be shown on the targets, I told you that. So all targets, your motion will be shown. If it is a stationary target, then the target will move in the opposite direction. Suppose this was an island or a rock, etc. Then this would move in the opposite direction, like the land, because it is stationary. And it will move at the same speed as your own ship's movement. But suppose this was a ship and it has got a course and speed, I told you course of 270 and the speed of 15 knots. Now how will the target move on the screen, this target?
Having this speed and the target speed.
Okay. It will be a combination of the target's course and speed and your course and speed, correct? So this is how you will see it moving approximately on your radar screen, which is not the target's course and speed, it's not your course and speed, it's a combination of both. And this movement on the screen is it is known as the relative line of approach of the target. And that target will continue to move on this relative line of approach as long as you are maintaining your course and speed and the target is maintaining its course and speed. That target will continue moving on this relative line of approach. And this is what we use for our radar plotting. Relative plotting. Yeah. So as far as relative motion is concerned, all targets will move on the screen, regardless of whether it is a moving target or a fixed target. Fixed targets will move in the exact opposite direction of your own course and at the same speed. Moving targets will move in relation to your own course and speed and their course and speed. And their motion on the screen will be known as the relative line of approach. Yes? Understood? So that is as far as relative motion is concerned. Now as far as true motion is concerned, once your gyro feed is given to the radar and your radar is gyro stabilized, you can have true motion, where your own ship's movement will be shown. Now if your ship was moving in that direction, in the 00 direction, okay, your ship will move on the screen on this line, and when it comes to about 1/8 from the end of the screen, the whole picture will shift back. Now, as far as true motion is concerned, what will be the situation with reference to that land? It means stationary. All stationary objects, suppose there is an island or a rock or whatever, that will also remain stationary. And now that ship which was here, how will it move? On the screen.
Whatever its true course.
True course and speed. So it was moving 270 at 15 knots, so the ship will move in the true direction. The advantage here is you can make out the exact aspect of the ships. And how is it going to help you? The aspect. Applying all and to find out what rules are applicable and who has to keep out of the way. In relative motion, can you get the aspect of the targets on the screen?
But we can get the CPA.
Yes. You cannot get the aspect. But you can find out how the ships are going to pass you. Whether it is going to pass ahead of you, pass astern of you, whether there is close quarter situation, collision course, whether she is going to pass clear, all this can be observed from the relative line of approach. Whereas in true motion, you can actually see the motion of the ship. Your ship will also move, and the targets will be moving on their course and speed. And thereby, it becomes very easy to apply suppose you will know what is the situation between your ship and all the other ships. Yes or no? So that is your different types of motions as far as true motion and relative motion is concerned. Now we come to presentation. There are different types of presentation which you can use. First, the head-up presentation. What is head-up presentation?
What are the ship's headings? What are the ship's heading? It will be come to the 000.
Head-up presentation. First and foremost, what does this PPI represent in the head-up presentation? When you're talking about head-up presentation, how does this PPI, rather this 360 degrees around the PPI, what does it represent?
Heading.
Heading. Huh? 360 degrees on the PPI. Now we are talking about head-up presentation.
Gyro. From
Ship set, sir. Ship set.
Straight. So if I am steering 060, let us say, where will your heading marker point?
0.
060.
If it is a true north,
I'm talking about relative motion head-up presentation.
that will be
000. Okay. So the heading marker is going to show 000 direction. Now, let us say there is a landmass over there, and there is a ship 30 degrees on my bow, another ship 60 degrees. Okay, this is 60 degrees on the port bow, which is say 300 degrees. Now, these are the ships which are outside. This is a landmass outside. When I look outside, will I see the same picture?
yeah. Yes, sir.
So in the head-up presentation, whatever you are seeing outside is what you will see exactly on the screen. That is head-up presentation. So here the 360 degrees around the PPI does not have anything to do with the compass. So what does it represent? If it is not the compass, the 000, 090, 180 and 270, what does that represent? This has got nothing to do with the compass. First thing you must understand in the head-up presentation, no gyro stabilization. Head-up presentation was the only presentation that was used in the early radars. There was no gyro invented at that point of time. So when there is no gyro, you can't have gyro stabilization. And when there is no gyro stabilization, this 360 degrees on the PPI does not represent the compass. So what does it represent? It represents 360 degrees around your ship. Okay, so this is what the compass rose represents in relative motion head-up presentation. The 360 degrees on your PPI represents 360 degrees around the ship. Now if I take a bearing of this ship and I get 030 degrees, what is that bearing? Relative bearing. So all bearings are not bearing the relative. How do you convert this relative bearing to true bearing?
Adding a course. Adding.
At that time, when you are taking the relative bearing, you also must take the course that or the heading of the ship and apply that. If it exceeds 360 degrees, then subtract 360 from that, you will get the true bearing. The ship, when if I alter course now from 000, I said I was heading, my heading was 060. If I alter course by 30 degrees to starboard and I steer 090, what will happen to the heading mark then?
090 will come up.
No. I told you this is not gyro stabilized, so there is no question of 090 or 060 coming on the top.
Heading marker will be 00.
Heading mark will remain on 000. How your picture is going to shift. Now if I altered 30 degrees, this target will come here, this will shift 300, it will become 270. Okay, and this landmass will also shift 30 degrees to port. I have altered 30 degrees to starboard. So this is where your picture will shift and your heading marker will remain stationary. Yeah. However, if your ship is at anchorage and your ship is yawing, you know what is the meaning of yawing? Yawing, the ship's head is moving from side to side. What will happen to the picture? The picture will keep shifting back and forth, and therefore smudging will occur. So smudging of pictures Can you compare this picture with the chart? Is it possible to compare this picture on your screen, on your radar screen, with the chart? No, because obviously there is no gyro stabilization. Okay, these are all the disadvantages of your head-up presentation. However, there are two main advantages as far as the head-up presentation is concerned. What are the advantages? Main advantage. What you're seeing outside is what your what you're actually seeing is what is being shown on the and that is called orientation. Yes. Wait. Orientation. Orientation means whatever you're seeing outside, blocking the camera. Whatever you're seeing outside is what is going to be shown on the picture. That is why earlier we used to have pilots, especially in the Suez Canal, Panama Canal, etc., wanting to use the head-up presentation. Even masters, when you are approaching ports, etc., anchorages, you want to see what is happening outside and the same picture on the radar screen, the orientation. What is the other major advantage of this head-up presentation?
Application of always will be.
Other main advantages.
In 300 meters, turn right.
Okay, the other main advantage is that your radar can be used even if your gyro fails in the head-up presentation mode. Today all your RPAs are programmed so that Even if the gyro fails, automatically it will go up to the head of presentation. If it is not programmed like that, you will always be able to change over to the head of presentation. So your head of presentation mode can work without the gyro. That you should be aware of. So the first thing is another gyro failure. Put the radar on head of presentation, and you can take your bearing in range of targets and do relative plotting. Will your ARPA work if your gyro fails? Will the ARPA function? No, obviously not. Without the gyro, your ARPA cannot function, but your radar can function. Your radar is independent of the ARPA. Though both are on the same screen, the left-hand side of the screen you have the PPI and you have alphanumerics. That is your radar part. The right hand is the alphanumeric, that is the ARPA. The ARPA can fail, but your radar can still work. And you can use the radar in the head of presentation mode, relative motion, head of presentation, it will work. And that is the main advantage of this head of presentation. Okay. So that is head of presentation. Now, let us go to north up. In the north up presentation, your gyro feed is given to the radar, thereby it is gyro stabilized. And now when your radar is gyro stabilized, what does this PPI represent?
Direction of the, like, if the true north is here, it will show true north 0, 0 degree here, irrespective of the, it will show a course.
Okay, so obviously this PPI now represents the compass rose. So 0, 0, 0 is north, 0, 9, 0 is east, south, west, etc. So this is the change. Now that you are given a gyro feed to the radar and gyro stabilize the radar, the compass rose now represents, the PPI now represents the compass rose. So now if I am steering 060, where will the heading marker point? 060. So that is what is the difference between your head up and your course up. North up. In the north up, first it has to be gyro stabilized. Okay. Now all bearings are what? If I have that ship which was 30 degrees on my starboard bow will be shown here now. Yes, on its true bearing. Earlier I was steering 060, I had that ship at 30 degrees on the starboard bow. So the true bearing was 30 plus your 60 degrees heading, which was 090. Now the ship or the target will be, your ship is steering 060. The target is 30 degrees on your bow, it is on the true bearing, 090. So all bearings are true. Is there any smudging on the picture? Now if I alter course, say from 060 I am altering to 090, what will happen to the picture? Say there is some landmass over here and there is a ship over there. There will be no smudging. Only the heading marker will shift. This ship will be right ahead of me. The landmass will remain in the same place. There will be no smudging on the picture. Okay, so smudging of pictures, no smudging. Is it possible to compare the picture with the chart? Comparison with chart? Yes. Comparison with chart possible. So all the disadvantages have become advantages now. And the advantage, what there was two advantages in the head-up presentation. One was orientation. Will you have orientation now?
No.
So this becomes disadvantages. No orientation. Yes? Will the radar work if your gyro fades?
No.
In the north-up presentation? No. It has to go back to the head-up presentation. So this is also cannot be used. Cannot be used without gyro. So all your disadvantages of the header presentation turn to advantages, and the disadvantages turn. Advantages turn to disadvantages. Yeah. This is as far as north-up is concerned. So what is close-up presentation? Close-up presentation. What do you understand by close-up presentation?
The course we are steering will be course.
Course your steering will be? Where will the heading marker point? So I am steering 090.
It will be right, but the course will be 09.
Okay.
000.
So as far as close-up presentation is concerned, what will happen is your heading marker will always point in the 000 direction. What will change?
Compass.
The graduations. The graduations are going to change, and you will have 090 on top. So this becomes, I am heading 090, so this becomes 000, and this 270. No, sorry.
Correct.
Yeah, correct. 000. 270, and this is 180. Okay. The graduation is going to shift. Whatever course you are steering, the heading marker will be pointing in the 000 direction, but the graduation will shift to show you the correct heading. So, in other words, course up is nothing but gyro stabilized head-up presentation. What are the advantages in the head-up presentation?
Orientation.
Orientation. Will you have orientation here?
Yes.
Yes.
Yes, sir.
Obviously, that is the reason why this course-up was introduced. Okay. So, as far as the orientation is concerned, whatever you are seeing ahead, you will be seeing it on the screen. So that ship which was 090 bearing, it will be shown right ahead. And if you are heading 090, that ship will be obviously right ahead of you. So orientation will be there. What about bearings? When you take bearings, they are all true.
True, sir.
True. Is this picture on the EPI? Can you compare this picture with the chart?
Oh, yes, sir.
Yes.
No, sir.
No, sir. Heading.
Heading is being shown, so no comparison with chart possible. Okay, so this is, as far as your course up is concerned, it's nothing but a gyro stabilized head-up presentation where you have orientation. Orientation is there. But if the gyro fails, will you be able to use this course up?
No.
Obviously not. Without gyro you cannot use. So, even though you have all the other advantages of the head-up presentation in the course of presentation, if the gyro fails, you will not be able to use it. Obviously, you need the gyro feed for the course to be shown. The rest of the things are the same. Orientation is there. Bearings here will be all like this is a combination of head-up and north-up. In the north-up, all bearings are true. Here also all bearings are true. But no comparison in the chart possible. Clear? Okay, now we are going to see this basics of your plotting, relative plotting. How to plot. Whenever you are plotting, first thing is you must have what is required for plotting? Bearing range of the target. So you want to plot a target, you must first take the bearing and range of the target. You must know your own course and speed, of course. Without your course and speed, you cannot plot. That is readily available to you. Course and speed of your own ship. The targets which you are going to plot, we'll take one at a time, one target. So the initial bearing and range of the target, at the time of observation, you have to note down the time. So let us say I take a bearing and range of one target at 0800 hours.
So the range will be from the radar itself.
Obviously. How will you get the range?
Yeah.
So let us say this, you are on a 12-mile range scale, and this target is bearing 040 degrees into 11 miles. So at 0800 hours, bearing of the target 040 and range 11 miles. For plotting, we allow intervals of 6 minutes, 12 minutes, etc. to make it convenient to calculate. So it becomes a decimal of an hour. So after 6 minutes, let us say at 0806, I take another bearing, it is 035 degrees into 9 miles. Then at 0812, I take the third bearing. And the range is 7 miles. Okay. My own ship's course is 000 degrees true into 15 knots. Okay. Now, I've got the bearings and ranges, now I have to plot. So, how do you plot? You use your paddle rulers from the course, take the range from the scale, you have to choose a suitable scale. So if on your plotting sheets, on the bottom right hand corner you will find the scales marked. Okay. So either you can use that or you can use your ruler, but whatever you use as a scale, you must constantly use the same scale. You should not change from one to the other, otherwise there will be errors. So as far as the scale is concerned, you must use the most suitable scale. Since the range, maximum range is 11 miles, you can use the 12-mile range scale. The scale which you use must be the maximum scale that can be used. Then your plot will be big and you will be able to plot accurately. The bigger the plot, the more the accuracy. If you keep it small, then that is going to be okay, then plot is going to become very small and the accuracy will reduce. So I'm using the 12-mile range scale. I've plotted my first position at 0800 hours. Thereafter, it is 035. So use your paddle rulers again, 035, range from that scale and mark 9 miles. And the last position, let's say 030 into 7 miles. So you've got 3 positions. Now join all of these 3 together and extend it. What is this line?
CPA.
Relative line of approach.
Relative line of approach. We already talked about this. Relative line of approach. This is the line your target will move on. Provided the target will move on this line, provided what?
Same speed and courses.
No, as long as your own ship maintains her course and speed, and the target maintains her course and speed, the target will move on this line. If either one alters the course or speed, or both alters the course and speed, then the target will obviously not follow this relative line of approach. The relative line of approach will be different. Okay. Now that you have done this, now you have to name these to construct the OAW triangle. You have to name these points. So the first observation, what will you name that?
O.
O. Why O?
OW will be one as well.
Okay. There is no explanation for this. Anyway, the first point of observation is named O. The last one is named A. What is important to the first and last? And this is at 0812. This is at 000. Now, you have to put in your own course and speed. So from O, you draw your course, the reverse of your course. So 180, your course is 000. And for this period of time, 0800 to 0812, this is called the plotting interval, 12 minutes. The first and the last observed positions. The interval of time between the first and the last observed position is called the plotting interval. And that's very important because we always go back to the plotting interval. So the plotting interval is 12 minutes. Now for that 12 minutes, you must find out how much distance your own ship is going to cover. 3 miles. It's a mental calculation. Your speed is 15 knots. Okay. So now take 3 miles on this reverse course. Let us say 3 miles is there. This becomes, you have to name this. This is W. Thereafter, you join WA. What is WA?
Another target.
Target, course and speed. Once you join this WA, do not remove your paddle ruler, shift it, bring it here and read off the course, say let us say 290. So your own course you have put in, your speed, you have taken your speed, calculated where W will be, you have marked W, and then join WA and you have marked off the course. We'll come back to that. Now these must be marked with arrows. Your own ship WO is heading 000. So this is the direction WO. The target is heading in this direction, so this is WA. And as far as OA is concerned, since it is a combination of your own motion and the target's motion, it is marked with 2 arrows. So this is how you should mark the different segments of the OAW triangle. The direction in which the ship is heading, your own ship WO. The direction of the target is from W to A, not the other way around. So the direction is WA. And OA is the relative line of approach. Okay, so OA on the OAW triangle is your relative line of approach. Okay? Clear? And she will continue to move, the target will continue to move on that relative line of approach as long as the target vessel maintains the course and speed and your own vessel maintains the course and speed. If either one of them alters course or speed or both, then it will change. Then OA is your relative line of approach. WO is what? Course. Own vessel's course and speed. Okay. WA. That is as far as the triangle is concerned. Now we have extended this relative line of approach. From this, you can also find out CPA, TCPA. How will you do that? For finding out the CPA, TCPA, what you have to do is
Take the parallel.
this is the central point, so this is marked as C. Okay. Through C, you have to draw a perpendicular to this line using the parallel ruler. You draw perpendicular to this. What do you name this? N. Nearest point of approach. So CN is what? CP. Closest point of approach. Okay. This you can measure with your dividers, measure against the same scale, and you will get your CPA. Let us give it some distances so that we can calculate. Okay, let us say this is 3 miles, that is what your speed was, and this is 5 miles. So you can start calculating your course and speed. You already found out your target scores. Target scores, we have approximately, we said it is 290 degrees. And target speed 5 miles in 12 minutes. So what is the speed?
25 miles.
25 miles.
25 knots.
25 knots. Okay, so you already got the target scores and speed. Now to find out the CPA, we said we will measure this and let us assume that it is 6 miles. The next step is to find out your TCPA. How will you find out the TCPA?
Distance from
The
the
distance from A to N.
A to N.
A to N. The target has traveled from O to A in 12 minutes. Okay. How much time it is going to take to travel from A to N? So, calculate TCPA. AN upon OA into plotting interval. What is the plotting interval?
6 minutes.
12 minutes. First and last. So let us say AN in this picture, let us say it is 4 miles. No. Okay, what is it? 4 miles, and for convenience sake, I am taking OA as 6 miles into 12.
8 minutes.
So 8 minutes. Now this TCPA, you are taking it from this
8
time.
plus 8.
So 808
0
12 plus 8 minutes is equal to 0820. Yeah. So you have got your CPA, you got your TCPA, you got lone vessel's course and speed, target vessel's course and speed. Now you have to find out what? Aspect. Aspect. What do you understand by aspect?
From the target versus how it is going to see our.
Aspect is how the target is viewing you, not how you are viewing the target. Okay. Aspect is how the target is viewing you. So how will you find out the aspect? To find out the aspect, you already know your own course. That is your course. So it is, aspect is how the target is viewing you. You are at the center. So this angle is the aspect.
90 degree.
So you can actually measure this with your protractor and find out. Alternatively, you can also calculate it. You know your target scores. Target scores is you know the targets bearing at A. 030. 030. So you can find out what this bearing is.
Both side.
290.
290.
The reverse of your target's bearing is 030
90.
plus 180.
210.
210.
The port 80.
So the reverse bearing is 210. The difference is 80 degrees. Okay, this is your aspect. 80 degrees. Now we have to name it red or green. Is it red or green?
Red.
We are on the port side of the target. So this is red. 80 degrees red. That is the aspect. Aspect is always how the target is viewing you. You are in the center of the screen. So whichever side you are from the target, it will be named red or green. So if you are on the port side of the target, it will be red. If you are on the starboard side of the target, it will be green. And this is how you name the aspect. There are only two occasions when the aspect will be neither red or green. When is that?
Head on.
If it is head-on situation, what will be the aspect?
0 0. 0
0 0. Yes. I just wanted to find out whether you're sure. So if it is a head-on situation, the target is coming exactly opposite to you, then it is 0 0 0. If on the other hand, the target is right ahead and you are coming directly behind the target, then what?
It will be 180.
180.
180.
So only on these two occasions there will be no red or green. Otherwise, it is always named red or green. And the aspect is always measured 0 to 180. Red or green. Yeah. So this is as far as your plotting is concerned. The basics. OA is your relative line of approach. First and last observed positions, plot it, and then extend it. That is your relative line of approach. Then you put in your own course and speed from O reverse of your course. Take the time between O and A, that's the plotting interval. Find out how much distance your own ship will cover for that plotting interval. And from O, mark that point W, that is your own course and speed. Thereafter join W and A, that is the target's course. And the distance covered by the target between W and A is for that plotting interval 12 minutes, interpolate it, find out the target speed. And you have to find out the CPA, TCPA. To find out the CPA, through the center, draw perpendicular to your what? Relative line of approach. Measure that, that is your CPA. Find out from the scale. And to find out the TCPA, AN upon OA into plotting into it, measure both, interpolate, you'll find out the TCPA. Add that to this time. Okay? That is your TCPA. And the last aspect is the, in plotting, the aspect is how the target is viewing you. So which side of the target are you? You are always at the center, and you can either measure that angle between the target's course and your relative bearing from the target. Or alternatively, you can calculate it. You know the target scores, you reverse the bearing, and then the difference between the two gives you the aspect. Aspect is always named red or green, except on two occasions when the target is right ahead on a head-on situation, 0, 0, 0, and the target is right ahead going in the same direction, it's 180. Yeah, so this is as far as your plotting is concerned. And in your plot, you must not, even if you draw all these things, I drew all of this to explain it. Okay, you do not draw any extra lines in the plot. Even the perpendicular ones you mark at the end, you rub it off. Okay, that's all you should be there on the plot. No extra lines. Thereafter, you have to report this in the initial plots. They ask you to report to the master. Report the target at 0. Please stop talking. Report the target at 08. How will you make a report? First, first part of the report, the bearing of the target at 0812. Zero, 30 degrees. True. Now, you have to mention whether it is drawing forward, drawing aft. What do you understand by drawing forward, drawing aft? If the target is moving towards your course, this is called drawing forward. The first bearing of the target I told you was 045. The next one was 040 or 040, then it's 035, 030. Your own course is 000. So the target is moving closer to your course. So the target is drawing forward. Correct. Now the second part of the range . Last observed position at 0812, the range was 7 miles. Now, this was the first range I told you was 11 miles, then 9, then 7. So is it increasing or decreasing? Decreasing. So range of target 7 miles, decreasing. Okay. First is bearing and whether it is drawing forward, drawing aft. Here it is drawing forward. Range, whether it is increasing, decreasing, decreasing. So obviously the target is coming towards you. That's what this indicates. Then the course and speed of the target. Course 290. 25 knots. That's a complete report. So when you are asked to report a target at a particular time, this is how you have to do. And this report will change according to the time. Suppose he asks you to report it at 0818. Then you have to find out the projected position of the target at 0818 and then report at 0818 or predicted position. Predicted position is very easy. The target is moved from 8 to 812, so much distance. How much did you move in 6 minutes? So with that, the basics of your plotting is covered. Thereafter, you can start doing your plotting. So.